Okay, so we are looking at branch statements in our last video. We presented to you some problems that you should try to work out in the last few slides. In this video, we are going to look at another form of statements in Fortran, and we call them loop statements. So, just a little bit of background of where we are coming from. In our first video, we presented to you two types of expressions. The first one being the relational expressions, then we also looked at logical expressions. Under relational expressions, we looked at how we can use the following operators, like maybe greater than, less than, equal, and other expressions like greater than equal to, less than equal to, etc. or not equal to. Under logical expressions, we are looking at how we can use and, we can use or, we can use equivalent, we can use not equivalent, and how we can use not to evaluate Boolean values. Then in the last video, we are going through branch statements where you have to make some decision and execute a portion of code and leave or skip other portions of code. So we looked at three forms of if statements, starting with the basic if. Then we went to another type of statement which we call if else, and lastly we looked at if else if. Then another form of course statement that we went through under branch statements, select cases. So we went through the structure of a select case and how the case expression is matched against the values under each case. Now here we are looking at the loops. In programming, we are presented with problems that require repetition. And of course, in our everyday life, we have problems that require repetition. So instead of writing maybe code repeatedly, we can write that code once and use the loop statements to help us do or execute that line of code repeatedly. For example, if we want to print maybe a name in Fortran, maybe we want to print it 10 times. We can use, of course, print statement. Print statement, then we put the name in quotes as we have been doing using the print statements before as an output statement. So we will write that statement, print maybe 10 times. But what if we want to print the same name maybe 100 times? What if we want to print it 1,000 times? So it means we have to write print 1,000 times. So it's not practical, but there's a solution, a better solution to do that. If it's something that is repeating, it has got some pattern, for example, we can use the loop statements to do so. So it helps us to execute statements repeatedly. So instead of writing 1,000 times to print 1,000 times of our name, we can just have one statement that should be executed 1,000 times. So it saves programmer from writing the same line of code now and again. You can use one statement and just execute it so many times. So that's why we have loop statements. So in bit of a maybe definition, we are saying loops are Fortran constructs that permits us to execute a sequence of statements more than once. So we execute a statement repeatedly. We have two basic forms of loop constructs in Fortran. We have the while loops and the counting loops. So with the while loops, the code is repeated an indefinite number of times. So the while loop is a definite loop, while the counting loop is the definite loop. It has got a specified number of times that the loop is allowed to actually execute, and that information or the number of times it is going to execute is known prior to the execution of the program. So we are going to see how the two differ by looking at the structure as well as the examples where the two can be actually used. Starting with the while loop. To create a while loop in Fortran, we start with the keyword do and we end with the keyword end do. So anything inside here is considered to be a body of this loop, so we call it a loop body from the do up to the end. And inside here we can have statements before the if statements, and we can have other statements after the if statement. Our if statement here is just a condition. We have if statement and our logical expression where we will have maybe a statement to be evaluated to true or false. But if this condition is evaluated to false, then the statements below this if statement will be executed and the loop will repeat. Executing statements here, checking this one, if it's still false, it will execute here and repeat the loop. But when the moment the if statement here executes to true, then the exit statement will be executed and our loop will terminate. And the statements after the loop, statements that are here, will now start executing. We'll start executing a statement that is immediately after the end do, and the program will continue executing up to the end of the program. So that is a flow that we have for the while loop. So this is a common structure that you may find in many books and maybe many code implementation of the while loop. We have the if inside to control the number of execution. So as you can see, you may not tell maybe in advance how many times this program is going to execute. It depends on this logical expression being evaluated to true. The moment it's evaluated to true, then our loop will be able to exit. Another form of while loop is this one. Instead of writing it with if statement as we did before, you can have your while loop like this, where you have do followed with a while keyword, then you have your logical expression here. That should always be true for this loop to execute. The moment this logical expression is false, then our loop is going to terminate. But the moment this one is true, then our program or our loop is going to be repeating. So this is another form, but the previous form is more common as compared to this one. Okay, so here we have an example. A program to calculate a given set of non-negative integers, assuming that the sum of the set is not known in advance. So we want to maybe enter a number or set of numbers and calculate the average of that number. So here we have our do, starting our do or our loop there, and we are ending our loop here. And we are making some assumptions here. This is just a portion of the loop, but the declarations and other things have already been done, and even some initialization of the values. For example, we are using a num variable here, which we are assuming is a variable of data type integer and has been declared before. And this statement is also using the sum variable. We are making an assumption that the sum has also been declared and assigned to 0, or has been initialized to 0. And we have another variable here called the count, which we are assuming has been initialized to 0 as well. Then we have average as another variable. So there are all these 4 variables that we are making assumptions that have been declared before the loop constructs here. So if we run this program, of course, every time we enter a value, we want that value to be added to a previous sum, so that by the end we finish adding the values here. by entering a number which is a negative, then our program should be able to use that sum and divide it by the number of count to get the average. So this is our example under while. On the side of counting, this is a loop that executes a block of statements a specified number of times. So it's called an iterative do loop or just a counting loop. And with this, there are three important things that we need to keep in mind. Of course, it starts with the keyword do, it ends with the keyword and do as before, but on the same line of do, we have the index or the starting value, and we have the end value. So the index is equal to the starting value, then the same index should go all the way up to the end value, then you specify the increment. So if the start value, for example, is 1 and the end value is 10 and the increment is 1, it means this loop is going to loop 10 times. Every time this loop actually loops, it means the value will be changing from 1 to 2 up until it reaches to 10, because our step is actually 1. If our step is 2, it means our loop or the statements inside here will be executed probably 5 times, because it is going to be jumping 2 steps. So from 1, the next loop, the value of index will be 3, the next time will be 5, all the way up to 9. The moment it reaches 11, it will be executed, evaluated to false, then the loop will end. Okay, so here we're just showing you some examples of how those statements are used. For example, here, if the step is 1, in most cases we don't specify. So we can just have I equals 1, 10. So this is going to evaluate 10 times. This one, I equals 1 up to 10, and the step is -1. So this one is going to start all the way from 1 and is going as a final value of 10, and we are using -1 here as a step. And here we have I 1 up to 10, and our value is 2 as a step. So this one is going to increment 2 steps from 1 up to 10. The negatives are used to increment backwards from the value that you have been given to the lowest value that you may have. So for this example, the order here is not very good. We're supposed to have starting from maybe 10 up to 1, so that the counting should start from 10. We'll be reducing it by 1, 1, 1, 1 up until we reach somewhere where we have 1. Okay. An example, here we have an example where we are getting a factorial of a number. Remember, a factorial of a number, factorial of 5 is actually equal to 4 times 3 times 2, or 1 times 2 times 3 times 4 times 5. A factorial of 3 is 1 times 2 times 3, etc. So this one is trying to calculate a factorial of any number that you are going to give. If it's 5, then it's going to calculate a factorial from I equals 1 to 5 using this calculation. By the end of this loop, it will be able to give you a factorial of any number that you provide as any. Okay. Then finally we have the cycle and the exit. The cycle is used to skip the current loop, and when the condition here is true and we have a cycle, it means the statements below here will not be executed. The cycle is going to skip everything in this body of the loop, and the next loop will actually resume. So the moment the I is 3, we are saying do not print the value of I. Then just go and increment it to 4 and do the next loop. Exit, as we have seen before, the exit, the moment it's executed, the loop actually stops immediately. Here we are saying you can also have the name of the looping. You can have a name here, We'll explain better about the names in the next video. Thank you.